Okay, so my next move will be to remove the microcontroller from this Arduino. And then we're basically going to hotwire another microcontroller, a standalone chip, to this Arduino, tricking this Arduino into thinking that that microcontroller is its microcontroller, when in fact, well, it is, but it's just connected not in the normal location that a microcontroller would be connected. Instead, it's connected onto the headers through jumper cables. So basically, this is just a way of utilizing the FTDI USB to serial converter chip in order to enable USB communication The only problem is this. This is not a micro USB. This is a big boy USB. I think we should be able to drag one out though, so we'll be okay. But my normal setup won't favor that, unfortunately. Yeah, I'll just pull out a different type of USB for that. I guess this is like standard USB, and then there's the micro USB. Okay, so we need to desolder this microcontroller chip from this proto board, aka DCC Arduino Uno. Arduino knockoff. I feel like my heat gun would be the best way to do this. But we need to channel it. We're gonna need the attachment for channeling this thing, which I did buy. Where was this sitting just a minute ago? Where would I have put that? I'm gonna have to get it. I have to dig it out. Okay. So now back to the task at hand, gentlemen. We've got our heat gun here. And we want to funnel it. Oh, would you look at that? That's not going to be hard. All we got to do is pinch this thing down a little bit. And we'll be able to funnel the heat gun into a concentrated point. And I can't really imagine a reason why I wouldn't want it always to be concentrated at a point like why would you want it ever to be a wide amount of heat? I don't know. Heat shrink tubing, anything like that. It seems like concentrated point would be just fine. Ooh, nice solid fit. You just had to pinch it a little bit. Well, I guess I have a good combination of chaos and cleanliness because my room's very organized, but there's a lot going on, so it's like organized chaos, I would say. Nice. You know what? This is going to work just fine. Okay. So, let's get to it. our goal here is to desolder a tiny, tiny, tiny microcontroller from this Arduino. It's a TQFP or something like that. It's a form factor that's not like, there's the ATmega 328P that has a DIP form factor. DIP means like this. Here is DIP. It's easy to solder to. Well, not really easy. It's still hard to solder to, but it's like something a human can really mess with because it's bigger. The pins have separation. 4 pins are the width of my thumb, or 5 pins are the width of my thumb. You know, it's a decent size. Now, compare that to this right here. This is the same exact chip. It does the same thing, has the same number of pins, but it's just a smaller form factor. That is hard to solder to. So even to get it unsoldered from this board, I'm going to use this Katona Tools heat gun from eBay, straight from China. And I just bought a separate attachment of different head nozzles for it. So this is going to narrow it down to a tinier opening. And normally guns like this you buy and they're like really expensive, but this is the most ghetto possible version of a heat gun thing for electronics. It's really not like never done this way, but I think it'll work. I don't see why not. So I'll be able to like move it around with this needle nose pliers, I guess. And hopefully we'll be able to get it hot enough to where it will just pop right off. What the hell, dude? It came right off. I am blown away right now. I mean, it theoretically could work, but I got, you know, you have to buy a specialized electronics heat gun to make it work, right? Apparently not. My ghetto 1500 watt Chinese heat gun with a bush down nozzle. I mean, a combination of about $20 to get all this stuff, I think. Something crazy low. And it just did something that a multiple hundreds of dollars Weller tool or whatever would have done. That is super cool. Yeah, I'm going to use a solder wick now to go through the pins. You can see here, there's a little bit of smearing. If it'll focus. There, that's a nice focus. I don't even think you can see the pins, but it was right here, and I don't know how well you can see, but there might be some shorts, like right there. You can kind of see on the bottom left, because it kind of smeared as it came off. So anyways, yeah, I'm gonna go over it with solder wick, and we should be good to go. But yeah, I don't think solder wick would have taken that chip off, because it was so small that the solder wick probably wouldn't pull the solder off from underneath the pins. I think there'd still always be a little bit of solder. You'd end up having to tear the chip off or something like that. So just heating them all uniformly at the same time, I think, was a superior approach. And that's the way any like pro electronics guy would have done it, except he would have used a more professional heat gun thing. I don't know what they're actually called. Is it a hot air rework station. Is that what it's called? I'm not sure. Wick with the heat gun. Oh, interesting. Oh, I hadn't thought of that. That's not a bad idea, but I can just switch to soldering iron as far as like pulling off whatever I didn't get yet. Well, shoot. It's not even that bad. I could probably not even need a soldering wick. I just need to make sure they're not short-circuiting each other. Not that... I mean, I don't even know if that would be an issue to begin with, period, but... Okay. So I'm just like... flicking the soldering iron right over it, basically. I just don't know if these little, solder pads should have solder connections bridging them. And I think the answer to that is a definite they should not. So I'm just making sure there's no bridges. Okay, let me pull this back out. I'm like so happy that my heat gun with the little nozzle I bought for it actually worked. I'd never tested it till now. And it just achieved something very critical for me. So now this microcontroller has, or this, let's say this prototyping board now officially has no microcontroller on it. And what that's going to mean is that if we connect a standalone microcontroller to the right header pins, we'll be tapping into the functionality of the board, specifically the USB converter, so that we can install software onto our standalone microcontroller, which is this. So this microcontroller, wired in a special way to this board, now that this board has no microcontroller, will be detected as being the board's microcontroller. We're tricking this board into thinking this is the microcontroller that goes right here, even though we're just going to be hot wiring it to the header pins. And it will be treated as if it were the microcontroller that came with the board. So using the board, then, we can program this thing. And this was the microcontroller that came with it. And it is tiny. Okay, so I just want to look at this microcontroller real quick. Alright, there's no solder bridges. So I would like to actually try to deadbug solder to this thing. It's an ATmega 328P. Oh my gosh. I'm really sick of that happening. Little hands of my third hand tool keep popping off. Okay. So I put that heat gun away. I think we're done with that. Put this down. I go back to inspecting this. ATmega 328P AU 1505. AU is the form factor, I guess. So this is the impossible to solder onto with human hands form factor as far as Deadbug goes. But we're going to try to do it anyways at some point in the future. Because hashtag YOLO. I want to see if I'm capable of it. Because just because some people aren't, or it's known for being a pain in the butt, doesn't mean I won't be able to. There's also a trick to doing it. You got to lay down number 30 wire in a grid pattern and then drag solder it, and then you cut away the center of the grid, and then that leaves you with Deadbug wires that you can then attach to from there. So I've already found out how it's done. Now I just have to do it. I think it shouldn't be that bad. Should be a fun challenge. And who knows when I might want to be able to use a microcontroller with a really tiny form factor like that. Okay, so that was a big win. Now we have to do our wiring. I'm going to use this thing's wiring as reference. Well, I'm excited. That was like the biggest question mark, is how the heck will I be able to get that tiny little microcontroller off of the board? And the heat gun idea worked great. That is a big, big win. Huge morale boost. Yeah, I agree, Marimore, which is why I put pressure on the microcontroller while I heated it, so that the minute it got hot enough to liquefy the solder, the microcontroller would pop off immediately without melting off any other components or anything like that. So I didn't want to have the heat on any longer than I needed to. But the heat was very concentrated, so I think that the risk of desoldering any other parts by accident was pretty low. Okay, so now it just comes down to a ton of wire stripping, pretty much. In fact, I'm going to be doing so much wire stripping right now that I'm going to look up jumper wire stripping, like, how-to guide. Yeah, I've done it in several different ways. I find that using my wire stripper tool, my strip master, just tears them right in half when it comes to jumper wires, because it's such fine copper and there's only like 3 little strands of it. I want to know the easiest way. Oh, his jumper wire is solid core. You see that? I wonder if he's not having any issues. But I'm using the stranded kind. Alright. I couldn't find anything, so we're back to square one. Let me just whip out some wire and just get going, whatever. A little unfortunate, but it is what it is. Okay. If anybody has any tricks, I am streaming under robotics, so one of you guys might be a pro at this. I had a friend who was taking electrical engineering classes, and he said he had great luck with using a nail clipper like this. So we'll see how this works. Oh my goodness, that was not too bad. Beautiful. Hi, Mr. Dibna. How are you? Ugh. That's not what I wanted. Deck, nabbit. Let's try that again. Wow, fingernail clippers work great. So we got one wire ready. I want a super long wire next. This will be my epic long black wire. What am I up to? I am doing robotics. robotic electronics. Just like a good little roboticist. That I am. Okay. So right now I'm measuring the first part that's going to solder onto my socket. This part's going to be the crystal resonator. This part's going to be the capacitor. So like right here you can see this wire connects to the socket, this far right black wire, and then it comes to the crystal resonator here. And then there's a little gap in the copper, and then there's a little more insulation, then you come to the capacitor, and then there's more insulation, then you come to where the capacitors meet at a wire right here. So yeah, I'm just trying to copy all of that as easily as possible. Whew. One joint, two joint, three joint, and then ends. Whew. So scary. Okay. Um, well, this is going very well, gentlemen. And then the final thing will be... You know, I think I'm going to solder directly into the board this time, as opposed to plugging it in the header. Wait a minute. Yeah, I can do that. Solder it directly in the board, and then it's going to a socket. Yeah, that'll be good. Okay, so we got our 3 joints. 1, 2, 3. And then this part will stub directly into the board. So good. Man, now that I know how to use a fingernail clipper for this, it is just so much easier. This is not actually Adam's brain. This will be the brain of my switch mode power supply, which is a prototype for Adam's power supply. Adam's brain will be a full-blown gaming PC. Oh, nice. Okay, we got plenty of room here. Man, once you get the feel for it, this is so fast, man. I'm becoming a beast with this nail clipper. Okay, so that's that. Okay. That's that. Okay. And then they join right there. I just can't believe nail clippers not only cut the wire, but perfectly strip it so fast and easy. That should be industry standard way to do this. There's no way anything could be better. It's so funny that my brother-in-law, my new wife's brother, I just asked him, how do you strip little jumper wires? And he said nail clippers. And I just thought, like, oh, he doesn't know what he's talking about. And he was like, onto something big time. Imagine he must have seen classmates doing it too, and who knows how much, like, knowledge is passed between students at a school. Because their dads might be involved, they might be engineers. There's no telling where that information's coming from. Maybe even the teacher suggested they do it that way. Well, I'm ready to start soldering, I think. Are you still making the robot? What does it look like? I'm making the robot right now. Except not really. I am building a switch mode power supply for my handheld vacuum. But I still consider it working on the robot because that is the prototype for the power supply that will run my robot. So it's a power supply I designed. Um, I think we're about there. And that one can go to here. And then this final one can go... I think we'll keep this full length. I'm not gonna blow myself up. Beautiful. Alright. Now it's all soldering time. Now this is the fun part. I mean, that was not too bad though. I remember the last time I did wire stripping, it took forever. That was nothing. Okay, so... I'm not even sure what's the best order to do this. Okay, I'm gonna do all the components. I'll start off doing the crystal, and then a capacitor, then a crystal, another capacitor. Wait, no, I'll start off doing the Y joint, and then I'll do the crystal and capacitors. And then I'll do the next Y. How about that? So first we have our first Y, which is here. And then this guy. Just gonna wrap around it. Okay. No, the hand vacuum won't suck harder, but it will, what will it do? It will be able to run direct from the wall, as opposed to only running when it has battery life. So I'm creating a power supply that can provide enough power to power the vacuum when it's plugged in from the wall. And it will not use batteries during that time. It could even be charging while running from the wall. So when it's plugged into the wall, it can be charging and running at full steam. So that's nice. So while you're using it, the batteries are charging. And then, when it's not plugged in the wall, then it switches to battery mode. And then it uses the battery life that's in there. And I'm going to be setting all that up, including including a custom designed battery management system, which is really efficient and state of the art, which I've already created the design for. Okay. Alright, we got our first joint done. Elon Musk copies me. He just doesn't know it yet. I will surpass Elon Musk. In every way imaginable. He might have beat me to a lot of things because he's older. But I will, in the end, outdo him. Okay. So we got that done. Now, I figure we can do another Y joint. Why not? Alright, so there's our second Y joint. And alright, let me put the next Y joint in the same spot. Well, I don't have to. But I guess I will. This will show me if we can do double Ys or not. I suppose it shouldn't be an issue. Some duct tape around the chair? Yeah, I plan to eventually do something with that. Maybe I'll do goose down padded armrest. Yeah, it's an AC/DC adapter. That has the power to not only charge the batteries, but also power the motor of the vacuum. And then there's a separate battery charge controller or battery management system. And that will also be in charge of determining whether it's plugged into the wall or not. And if it's plugged into the wall, it will use direct power from the wall. If it's not plugged into the wall, it will tap into batteries. Okay. So now we can solder on our capacitors. And I already have all the parts needed for the whole project. Well, for these steps that I'm doing over the next hour. I have all those parts pre-selected just to save time. I was thinking ahead. Alright, so I'm just splaying the legs outward of the capacitor. And now I can mount it onto my wire. Okay. I feel like making the adjustments of your helping hand is like the most important and time-consuming part of doing any electrical joint soldering work. I wonder. Huh. Whoa. You can do it. Okay, that's interesting. I want to try this. So I'm sliding the leg of the capacitor inside the insulative sleeve of the wire. This is kind of a radical thing I just came up with to try. Might be really easy once you slide in the leg. It's like a sleeping bag. Heck, I might not even have to solder it then. If it's slid all the way into the jacket. This is hilarious. Wow. It worked. So look at this, guys. I slid the legs of the capacitor right into the insulative wiring. I just slid it in. There's good electrical contact just from that. Um, I have to clip away the wire in between. You know, I'll still solder it, but that's just gonna... That was just a pretty cool trick. Did I just invent that? Newbie on campus over here changing the game. I'm changing the way the game's played. I'm making my own rules. Oh, that was a terrible joint. Okay. So there's my finished joint right there. And we got our capacitor in. Just like that. Too easy. Ready for my next capacitor. How do you like them apples? This is a 22 picofarad capacitor, ceramic capacitor. It came from a capacitor assortment kit of various size ceramic capacitors. That email scared the heck out of me. Okay. And now we do our tuck. Alright. Preparation phase complete. There it is. There it is, all tucked away, ready to be soldered on the two sides, and then the middle can be clipped out after that. Did I already do the math for resistance? No, I didn't do any math. Everything's just, math free for me. So, I'm doing the non-math electronics version. But I still know what I'm doing, Mr. Dimna. I think. I feel that electronics shouldn't have to do with math. That's overrated. Like, okay, a buck converter, that doesn't have any resistors. And there are no resistors in doing what I'm doing, which is connecting a microcontroller to a microcontrollerless Arduino development board so that I can burn software onto a standalone microcontroller. There's no resistors there. So, yeah, I guess maybe resistor math comes into play for certain electronics projects that I have not yet encountered in my electronics journey. I'll say this, even though I do consider myself the world's leading electronics expert, I am new to it. You don't have to be experienced to be the world's best. You just have to be the most capable, according to my definition. Alright, we're about to solder on our quartz crystal resonator. The manipulation of ones and zeros, well, all that's done with software on the microcontroller. All I have to do is figure out how to wire the rest of the components to support the microcontroller's functions. So maybe that's why you're doing a lot more math. Maybe you're using discrete logic or something instead of microcontrollers. But I just use microcontrollers for all of my logic. There won't be any timer chips in my projects. My timer is an Arduino microcontroller, or not necessarily an Arduino. I'm using the Arduino as a development platform, a development environment, but I'm using just a microcontroller chip for my projects. I'm not going to use the prototyping board. But it's still, I would say, considered Arduino, even though I'm not going to use the Arduino prototyping board. Oh my goodness. Fastest quartz crystal resonator installation in history right there, boys. And it's beautifully soldered. Camera, do you know what focus means? Sometimes I wonder. Unbelievable. I don't get it. These are my nail clippers. I already ate my baked eggs for the day. The guards let me have it. Let me have it early. I guess that's on account of my good behavior of late. Dang it! I stripped away a couple of wires on that. Ah, well. So, what's next? We got... Huh. You don't say. Well, it looks like... I mean, it has focused closer up before it. If it's too far from the camera, you guys can't really see that close-up I want. But I gave up. You'll just have to believe me that the solder job was really nice. Would I ever lie to you guys? Alright, I'm ready for my socket, I think. This is going pretty quick here, I feel. This isn't nonsense. This is robotics. This is what I get paid the big bucks to do on Twitch. What could be more roboticsy than soldering metal to metal, creating circuits? Like, that's the real deal. It doesn't get any more real than that. Okay, so 1, 2, 3, 4. It's on the 5th one. That's okay. Looks good. I'm gonna just play some flux on both. Pretaining is for noobs. Get wrecked, noobs. Man, am I getting faster? I'm a beast. Crystal, crystal, ground. Got it. I put black pepper on this time. That hurt. It burned me. But I didn't let go. 'Cause I'm committed. I'm all in. Robotics for life. Okay. Holy cow. We are flying. So on this side, it's 1, 2, let's see, 6, 7th one from the top. It's not ready to be plugged in. Seventh from the top, you say? Well, nobody says it's robotics when I do part fabrication. Nobody says it's robotics when I do software development. So I thought it stands to reason most people consider robotics this kind of stuff, soldering circuits together. That's what most people consider to be real robotics. It's the most mystifying because the software developers don't know how to do it. They don't know what's going on. The artists feel like seeing me fabricate parts doesn't count because they can do that. They know how to sculpt. This is the only part that people are like, oh, I don't know what that is, so that must be robotics. That's the part I don't get. Okay, so that just happened. And now... This goes into our ground. So most people don't solder into these boards, I bet. We'll see how it goes. It's not ruined, mailbox. Alright, so there's that solder joint. It's right here. We just went right into the board with it. And now we got the ground stuff done. What next? I'm very surprised how far we've come already today. They'll never throw away my dreams, Mr. Dimnos. They can't stop me from building my robot army. It's just a matter of time. Okay, now we need a big red wire. Um... Well, I mean, technically, you could say right now I'm prototyping a power supply design. That's going to be used for my robot. Except I'm going to be using this power supply on my vacuum. So that's not really robotics, I guess. Unless if... Well, I mean, it is if the power supply proof of concept for the vacuum ends up being the power supply design I use for the robot, and I'm just doing a prototype. I mean, that is then for the robot. Okay. So this goes like that, and then another one forks. Okay. Here's my circuit diagram. I guess I can show you guys the circuit diagram whenever I look at it. I drew that circuit. People think my circuit diagrams look like spaghetti, but I think they're easier to follow than the grid-shaped kind. Every time the lines cross, that does not mean they connect. They only connect if it's a T. Such as right here. That's a connection. That's a connection. This X is not a connection. This X is not a connection. That's not a connection. That's not. Now, a lot of times people will show a little loopy thing indicating they're not connected, but that's not my style. I prefer just to make sure that T's are connections, all X's don't count. It's just a simple way to do it, I think. Are you learning programming for my robot? No, I won't have to learn programming. I'm already a highly skilled veteran software developer in the professional world. I was a software developer way before I did anything with robotics or electronics. So I am highly qualified on the software programming aspect. I've already have a lot of experience with networking, advanced artificial intelligence, database design, security system design, networking, protocols, socket-based, and FTP style networking. So, yeah. Plus, I'm developing 2 video games, including my own game engines. And that's pretty much for the robot in a way because my physics engine and my 3D world in my video game with the custom engine will be also a simulation environment so I can run simulations for the robot's AI. I think that any phase of robotics is robotics, whether it's painting the silicone of the artificial humanoid robot's skin with an airbrush, which you could call that special effects, but that is robotics if it's for creating the appearance of your robot. Some people would say, well, that's just art, but any part of the whole, any phase of the development is still robotics. And electronics would be one of the strongest arguments for robotics as compared with part fabrication and software development. I would say electronics is the #1 most robotic-y thing. Software, #2, part fabrication, and all the artistic and appearance stuff is #3. But electronics is up there as #1 most iconic robotics related thing. Okay. So now we need a wire that goes to the reset and to the resistor. So that's like this. And okay. Uh, let's see here. Hmm. Okay. And now finally, we'll make this snip right here. Beautiful. It's like stealing candy from a baby. Alright, so I'm gonna do my Y next. You know what? Before I do any soldering though, I'm gonna just make my final Y. What the? Hmm. You know, I think I'll fork off the corner of the resistor. Okay. So that is going to go to the reset pin. From here. We're going to be out of red wire. Need to get some more. Okay. So that will come like that. Doing my wire layout on my stomach. I don't see any red wires in that batch. Oh well. Let's use these. Okay. Here we go. Man, I'm gonna get this done. I can see it right now. This is gonna happen, fellas. We're gonna get it done today. And I'm having fun. Okay, this connects to the second part, like that. That comes around to there. I think that should be long enough. Okay. Perfect. Big data and AI? Are you talking to me? My robot will have AI. I've already developed a lot of AI for it. I'm an AI expert. World's leading AI expert, in fact. You know, I'm actually the world's most comfortable roboticist as well, which I pride myself on. I always work laying down in my comfy chair. I have yet to see another technology expert as comfortable as I am while they work. Most work standing or at some kind of bench or hunched over a table. You gotta work reclined on your stomach. That's how you stay comfy. Comfort is key. If you want precision, you gotta get comfortable. Why do you think snipers at the shooting range lay down on their stomachs and slow their breathing? This gives you precision. Okay. Another one bites the dust. What's next? I want to do all my joints right now. I'd say he's next. Yep. I'm going to create a robot that automatically creates works of art, and I'm going to sell it and flaunt that in your face. Your art will be digital. My art will be sculptures and paintings that can pass off as having been done by human hands and charge accordingly. Okay. And then the resistor's got to be next. I don't care about getting something done in 5 years, as long as I get it done. I'll happily take being a multi-billionaire at 90 and staying hungry the whole time. If I achieved great wealth too soon, where would that leave me? That would leave me unmotivated. I'd maybe just start traveling the world with my wife. But if I stay on the broker side of a billion, then I still have something to fight for. I mean, if you're not a billionaire, then you're pretty much a worthless individual who didn't achieve much. That's the sad truth of things in reality. Billionaire is the minimum an individual should earn. Or else they're an utter failure. Why get rich at 90? You can do plenty at 90. You can start organizations. You can feed kids in Africa. You gotta figure, if I'm gonna live till 130, between the ages of 90 and 130, I'll be able to achieve a lot. I don't understand why this does not want to cooperate. Ugh. You pig of a resistor. Mm-hmm. Okay, I'm supposed to drag the insulation toward the resistor. That was my problem. I was trying to push the resistor into the insulation, but I should just line it up and then slide the insulation toward the resistor. That's it. Okay, so now I got it. I'll show you guys how it looks. There we go. So after I solder the two sides, then I can cut away the middle wire and it'll be good to go. If you want to be a NEET, start building a robot in your parents' basement like me. What do I have here? I have the makings of a circuit designed for the programming of a microcontroller. A standalone microcontroller. Okay. So that went well. Now what? Let's see. Okay. This goes like that. This goes like that. Okay. And now we need one coming off here to go to the reset. Okay. Perfect. Beautiful. Alright, so that's ready. Oh, yeah, I guess, I mean, it's so funny, like, how high level do you want me to describe it? Uh, at the lowest level, it's a bunch of wires to strap a standalone microcontroller to an Arduino breadboard that has had its microcontroller removed, so that said breadboard can install firmware onto the standalone microcontroller so it can run programs. So I'm using the breadboard just as a programmer of the microcontroller. At a higher level, I'm creating a prototype power supply for my robot, which will be used for my vacuum. Once the proof of concept of the power supply is proven by the vacuum, then it will go into the robot. So, yeah, that's all the things that are happening right now. Where does this go? Oh, wait. No. This goes this way. And this goes this way. Yep. Okay, the one on the right goes into the reset. Yeah, I can do this now. Well, no, I'm gonna put them onto the microcontroller first. I do not, console. That's a lie. I'm a man of science. I don't like sexual. Beautiful. Alright, and then this one. Goes to here. Perfection. Okay. And now, okay, the ground's on. This one goes to reset. And then this other one here. We'll go to above this, like that. Perfect. Man, I'm getting so much better at... Wait a minute. I put that 2 pins above. I was supposed to put it 2 below. I'm getting so much better at soldering these. Like, I'm getting way faster. Beautiful. Maybe in the hands of an amateur, unskilled individual who moves recklessly might be a little dangerous. In the hands of a master craftsman with flawless 20/20 vision, impeccable surgeon-like eye-hand coordination, a man who can braid the back hair of a flea without any magnification? No, it's not dangerous at all for such a man. Okay, this goes to the reset pin. At some point, this becomes a crime. I'm sorry, guys, but I'm getting a little too good at electronics now. It's really not fair. I gotta slow down. But it's hard not to become the best at electronics when you are the world's leading roboticist. Oh, you go in your little hole. Beautiful. Um, this went shockingly smooth. My goodness. What a thrill. We just have digital pins 0 and 1, the RX and TX pins. Oh, I can't just stop there. I have to do this. Stack nabbit. I'm way over on time. I was supposed to stop an hour and a half ago. But, those TV shows aren't going to watch themselves, you know. It's very important for a man of my genius to spend lots of time watching TV. It's how I shut my brain off and avoid becoming crazy. That's why I'm so sane and down to earth. So to cut multi-strand jumper wire, the fastest way is nail clippers. You just line it up, you pinch until you feel a little bit of give, or just eye it until it seems like you're hitting the wire. You rotate it 90 degrees, and you pinch again, and then you pull while keeping it pinched. And not a single wire is damaged. And with practice, it becomes really fast. Nothing can beat it. This fine wire really is too fine for wire strippers. Maybe some wire strippers are made for number 40 wire, but or for like really fine stranded jumper wire, but I've never had a pair of wire strippers that could handle such fine work without ruining or cutting some of those wires. And there's not that many strands, there's like 9 of them or so. Okay. This is a little long. Okay. This is the RX, or digital pin 0. I'm connecting now. Okay, that's done. And will that be long enough? Hmm. Oh. Wait, what? That was not the right one. You're coming off. I was going to start buying pre-cut jumper wire with the ends already snipped, but they snipped the ends like 1 millimeter, half a millimeter. It was not enough exposed wire. I don't know why they did that. You could always trim off more exposed wire if you wanted to remove some, but instead they just stripped off like barely anything. So I just threw the whole package away. And I'm glad I did now, because this way of stripping it myself is so fast. It's really kind of fun to do it with the nail clippers. It was brutal to do it with the X-Acto knife, but the nail clippers method is working out great. Okay. Perfect. Okay, the first one is RX. Put that here. Beautiful. And now TX. R is receive and T is transmit. So they're communications abbreviations or acronyms. Okay. And that's it. So we have Deadbug soldered this socket onto this Arduino with its microcontroller removed so that this Arduino development board thinks that this is its microcontroller. So now we can pop in any standalone microcontroller DIP package ATmega 328P into this socket and then plug the USB of this development board in, and this development board and USB and socket can then program the standalone microcontroller chip, which looks like this, with programs from your computer that you program in the Arduino IDE. So this will just pop right in, but it's kind of hard to get these in. You gotta bend the stuff just right, and this has some solder on it. I have to clean it up. I'm not going to do that right now. But yeah, I'll be able to pop this in, plug in the USB, create my program in the Arduino IDE, and then upload it. It's going to go through the USB to serial converter chip. It's called the FTDI chip. That's located on this development board, and that will convert it to a format readable by the microcontroller. And then the microcontroller will run whatever program I created in my Arduino IDE. So we'll start out by programming it with a blink program, and then we'll test it blinking a LED. And then once we do that, we'll start testing it doing some MOSFET stuff, and then we'll put it into our buck converter and start actually doing conversion, DC to DC conversion, lowering the voltage from a high voltage DC to a low voltage DC. So that's going to be super fun. I already have all my circuit diagrams planned out and drawn up in Photoshop. And yeah, it's just a matter of connecting everything up. I told you guys, all the hard work, the research, the understanding of this stuff, it's all been done. That's why I said I already consider myself the world's leading roboticist, because my designs, my plans, my understandings are all finished. And now it's just a matter of connecting the dots. I told you it's going to be just as easy as putting together Legos at this point. The whole robot has been designed completely. And if the robot were done today, it would be the world's greatest robot. So the guy that makes that has to be the world's greatest roboticist. Simple logic. I say that with all humility, of course. Yeah, I understand about scarring wires. I'm sure I did scar a lot of them, but there are like 9 of them, so if 2 were scarred, they might break, but we'll still have 7 more. It's gonna be a while before we'll see if this contraption actually works. This one did. So this is connecting a development board to a socket, and then using the development board as a in-circuit programmer. No, in-serial programmer, ISP. And we basically used one Arduino to program or to flash the firmware onto a ATmega 328P microcontroller, which is this, and we successfully got the firmware to go onto this thing. The next step is we created this second wiring schematic or circuit to use another board that will install programs onto this. So then once we're done, this microcontroller will be not only firmware installed, but programs installed, and it will be able to actually run. If you give it power, it will just do whatever your program told it to do. And so these 2 setups, one will be for firmware, one will be for program installations. And all we have to do is pop our microcontroller into one, get the firmware, pop it into the next, get the software that it's going to run, and then it's ready to go, and we can put it into our project. So this little thing will be the brains of any project we want. We don't need an Arduino or a Raspberry Pi. All we need is just this microcontroller. That will be the brains. A Raspberry Pi or any other type of microcontroller development board is just a bunch of peripherals. It gives you headers that are easy to plug into. It gives you a reset button. It gives you different power applications for powering it. It gives you USB to serial conversion, so you can plug it in by USB. But you don't need any of that. All you need is the microcontroller. The microcontroller is the heart of that board, and it has everything you need. So I'm just getting rid of all the fluff so I can have a much smaller form factor, same amount of power, same amount of capability. This is too big for most projects. This is a good size. And you can even go down to an even smaller chip if you have the skill for soldering. Even an even smaller microcontroller, which is this, next to my thumb to the left, as opposed to this. These are 2 identical microcontrollers with different form factors. The one on the right is called a dip package, and it's easy to solder to. It's got nice spread out pins. The one on the left is called like a TQFP or whatever package, and it is extremely hard to solder onto, but there is a way to do it. You lay number 30 wires in a grid pattern, and then you drag solder it, and then you cut out the center wires, just leaving the wires that are splaying out on the sides of the grid, and then you can solder your jumper wires onto that. And so I will be using that tiny, tiny, tiny little microcontroller for actual projects, for actual applications, and in situations where I need a lot of microcontroller and a little space. Such as like if I wanted to put microcontrollers in a hand, in order to handle all the sensory input, like the fingertips pressure sensors. I could put a little microcontroller, like I could put several of them in a hand because that one's so tiny. And I might not actually want something this big for the hand, although this would probably fit in the hand as well. But if space is really at a premium, I can use that little baby-sized one. So anyways, yeah, the next time I come on an electronics day, which is supposed to be once every 8 days, but ends up being more like once every 3 weeks or 4 weeks if it's tax time and I'm busy with taxes all week. Hopefully it will be like in the next 8 or 9 days though. We'll be able to do another electronics day. On that day, I'm going to get my microcontroller into this socket. I'll plug it in, and I'll plug in the USB into here, and I'll create a program in the Arduino IDE, probably just a flash program, just use the example one, to flash an LED. And then I'm gonna create a circuit with just the quartz crystal oscillator and 2 capacitors and a power supply, and that circuit will look like this. Right here. Wait. Yeah. Okay, so we've got a wall wart, 6 to 20 volts, a capacitor, a 7805 5-volt regulator, another capacitor, and then an indicator light, which is optional, indicating power's on, 220 ohm resistor, and then it will have a reset switch and another resistor. It'll have the oscillator and the 2 capacitors, and then it'll have an inductor coil, a 10 microhenry inductor coil, which is actually just a discrete component. It'll have a 100 nanofarad ceramic capacitor here, another 100 nanofarad ceramic capacitor here, 220 ohm resistor here, and an LED here. And this will run your LED blink program with this LED blinking. So yeah, that's your wiring diagram for having a standalone microcontroller. And I'm going to create that wiring diagram next after I put the blink program on it using the wiring diagram we just did today. So that will be my third and final wiring diagram to test out the functionality of a standalone microcontroller. I guess you can't call it standalone if we have all these little components deadbugged onto it, but I still consider it standalone because it doesn't have a board. It doesn't have like a breadboard or any type of board. It's just a little microcontroller with little wires coming off it. So it'll have a very flexible form factor that way. You can fit it anywhere and just put the wires wherever. So I think it's a good way to do it. I didn't know I had that light on this whole time. So anyways, yeah, we made great progress today. And everything's good. Things are going well. And we're getting faster every time we do this stuff. Faster and faster. Yeah, I don't like doing anything with breadboards and stuff because I want to get in the habit of doing Deadbug style non-board designs, because breadboards really limit your form factors, and I need to be able to fit these into the arms of a hexapod type robot, or into the finger of a humanoid robot's hand, or I mean, who knows what kind of nooks and crevices. You know, if I create a robot seagull, I'm going to need to fit little microcontrollers in its thighs and its wings and its chest and its face. If you're going to be creating different organic robotics designs, you don't want to be limited by putting these big old boards everywhere. So I don't use any boards in my designs. Everything's just Deadbug style, which means you just connect free floating wires to your microcontroller, and then all the components can just attach to that, and you'll be able to have it have any form factor you can imagine, and the wires can go in any direction you can imagine, and you're not limited at all to size constraints created by use of development boards or breadboards or vero boards. Those boards just force you into this rectangular formatting and take away all of your flexibility, which I don't like at all. Now I do have some vero board, which I plan to use eventually for certain projects, but it was my first priority to be able to successfully create Deadbug style circuits as a proof of concept so that I can always use that style of electronics work as opposed to circuit boards, because they are more conducive to organic electronics that can fit into organic designs, such as robotic animals and robotic drones and humanoids. I mean, breadboards might help if you need to do quick prototyping, which I don't ever need to do, because I feel all of the schematics I'm creating are from tutorials and guides or my own designs that are not really gonna need to change a whole lot for the final thing. Like, I don't get it. Like, I guess breadboards are for people who are impatient, maybe? Or just want to try random things. Like, just going through a bunch of tutorials online and they just want to whip out one after the next and then change the wires around and do the next tutorial. I don't know, but I see no real need for it. Okay. I got a lot of eating to do. Now it's just cooking and eating. And I'm going to end the stream here. So, it was fun to hang out. Thanks for hanging out, Miramore. Everyone new, welcome. And we'll be on some other time. Have a good day or night, guys. I'm going to watch... what's the show I'm watching? Chicago PD. I'm going to watch Chicago PD, which is a cop show.